So the algebraic methods of solving quadratic equations is we can solve some of these by factoring. Okay, so that's really should probably be our first choice. So if we can factor something like this, we should try to factor this. So if I draw my little factoring box here, I've got 3x squared, 4. I know that diagonal product is 12x squared. So I'm looking for two numbers that add to negative 7x. Okay, so that gives us our split and multiplies to 12x squared. So that's going to be negative 4, negative 3x. Okay, so then we end up with our factors, or the side lengths are going to be 3x, negative 4. That's going to be x minus 1. Okay, just double check that works. 3 times x. The greatest common factor is 3x. Greatest common factor here is negative 4. Yeah, so that all works out. So I can factor this into 3x minus 4. X minus 1 equals to 0. So from the first brackets, we can say x equals 4 over 3. And x equals positive 1. So the quadratic formula will also get set, but this is, since this is factorable, this tends to be a much easier way to solve it. So this one here, if we want to factor this, we first need to make it equal to 0. You might notice that there's an extra a in there, but that's okay because that happens to be a greatest common factor. And whenever we're solving by factoring, we always factor out the greatest common factor. So that's the first thing I'm going to do. I'm going to factor out the greatest common factor of a. Now I factor this normally. This has no leading coefficient, so I need to find two numbers that multiply to negative 30 and add to negative 7. So that's going to be, okay, since it's negative, we know one's negative, one's positive. So negative 10, positive 3. Those are our factors. So then the solution for x, we can say x equals 10 and x equals negative 3. We can also solve algebraically by completing the square. So that's our other algebraic method. And this does not rely on having to get a perfect square or factors that give us whole numbers like this. Okay, we can complete the square. So completing the square involves, first of all, getting rid of the leading coefficient out of the first two terms. And I'm going to move that plus 7 to the other side. So I'm going to subtract 7 from both sides. Now the reason why we do this is because we want a perfect square piece with the x's. Okay, if it's a perfect square, we can undo perfect squares with square root. So here to complete the square, okay, I take half of the middle and square it. I have to make sure I balance. So here I've got negative 2 groups of 4, so I've got to balance this side with the same negative 8. Once I have that, now it's balanced, I can try solving this. So the first thing I'm going to do is make the square. So this is an x minus 2 square. Okay, and now I can just solve this algebraically because I can undo the times, I can undo the square, I can undo the minus. So first thing I'm going to do is divide both sides by negative 2. So I get positive 15 over 2. I'm going to undo the square with the square root. Now, anytime I undo squares with square roots, they're not perfect. Squares and square roots are not perfect opposites, so we have to remember that there's a plus minus involved here. And then solving for x, we get x equals 2 plus minus square root of 15 over 2. And that solution is good enough because that's actually in simplified form.